Okay, so let's look at an example for 1511, if you can see that, for oblique impact. All right, we have two smooth discs, A and B. Remember, smooth discs, no friction, having a mass of 1 kilogram and 2 kilograms respectively. They collide with velocities shown. So A is traveling at 3 meters per second at an angle of 30 to the line of impact, and B is traveling at 1 meter per second at an angle of 45 to the line of impact. And we have a coefficient of restitution of 0.75. Determine the x and y components of the final velocity of each disk just after collision. Okay, so what's our game plan here, and what are the concepts that we need? Well, first is smooth. The particles are smooth. This means that what? If we establish our plane of contact, then there is no impulse in that direction because there's no friction. So no impulse in y direction because it's smooth. No impulse in the y direction. What does this imply? That implies that momentum is conserved in y direction for each particle. No, I'm not talking about the system here. I'm talking about for each particle, A and B. Because particle A, if you just consider the vertical direction, there is no external impulse for particle A and B if you just isolate them. Okay? What's the next thing? The next thing is that momentum is conserved for the system along the x-axis. So if we just consider the system along the line of impact, the x-axis, these impulses are internal to the system and cancel out. So momentum is conserved for the system along the x-axis. So those are some of the points that you need to get as we apply this, okay? So we're trying to find the x and y components of the final velocity of each disk. Okay, this problem is oblique impact. It's obvious. The velocity is, the center of mass of this disk is not moving along the line of action, line of impact. The center of mass of this disk is at an angle to the line of impact, so that is why it's oblique. So we can break up into x and y axes along the line of impact and the plane of contact. Line of impact is x, plane of contact is y. Okay, break it up into its x and y. First step, resolve each of these velocities into x and y, x and y. Okay, that's very straightforward. Remember that we've chosen the right as positive. So for VAX, right is positive and up is positive for y. Right is positive for x, up is positive for y. It's just our convention. So VAX is 3 cos 30. VAY is 3 sine 30, etc. I'm not going to go to that. That's straightforward. So we break them up. So now we've got our initial velocities in the x and y directions. So the components, these are all 1, 1, 1, 1. These are the initial velocities in the x and y directions. Okay? Now, I've mentioned this. We have conservation of momentum along the line of impact. Why is that? Because the impulses only act perpendicular to this line of impact, and so they're acting along the x-axis, and if we consider the system, they're internal. So momentum is conserved in the x direction. We have momentum of disk A in the x direction at 1 plus the momentum of disk B in the x direction at 1 is equal to the final momenta in the x direction. So mass times velocity plus mass times velocity is mass times etc. And you're going to have this here. Two unknowns in the x direction. Two unknown velocities in the x direction. Final velocities. Then the coefficient of restitution also is applied only in the x direction. Okay? And we apply it only in the x direction. Our coefficient of restitution is 0.75. Again, we get this equation. We have two equations, two unknowns. We solve and we get the velocities again, the final velocities after impact only in the x direction. VAX2. Okay, so remember, they were coming at this angle like that. They collided, and then A is moving in that angle, but it is going at minus 1.26. So the x component will be this. It will be going along the x direction in the negative direction, negative x direction, and B will be going in the positive x direction. Now, how do we solve for the velocities in the y direction? Well, we know for each particle, momentum is conserved. Okay? Why? Because there's no impulse in the vertical direction. So the velocity of A in the vertical direction does not change. Look, it stays the same. And the velocity of B in the vertical direction does not change. It stays the same. So it was minus 0.7, it stays minus 0.7. So this one is going down, that one is going up, the velocities do not change. Okay guys, does it make sense? I hope so. Okay, see you in the next video.